Chapter 13, Class 11, Limits and Derivatives. We have discussed about the limits and derivatives already. So we thought that we'll talk about algebra of limits in the next discussion. It is quite simple that you have two functions like fx and gx, and these are x plus 2, this is a line, so this is also a function, x square is a function, x cube is a function, combination of x square plus x is a function, sin x is a function. All these are functions. Some functions are what? Which gives you some value with some input value. So they have some domain, they have some range. All these we have already learned. So now the two functions, if you want to find out the limit of these two additions, then you can simply take the limit of this and add it with the limit of this. If you want to subtract these, then you can do it directly, or rather you can take them individually and find out the limits. Same is true with the product. You can take them individually. And what about the question? Question is like this. You can take the limit of this, take the limit of this. If you have a constant, you can take the constant outside and take the limit of this. So what about the polynomial and rational function, etc.? So if you have say a polynomial of this type, then you can take the limit of individually limit you can take. And this is nothing but, say, this is limit of x square. X square is what? Limit x into x. And I just showed you that limit of x dot x, you can take limit of x individually, and this limit of x you can take individually. So this is a, because x tends to a is what? Limit x tends to a, and this is x. So place a here. This will be a. So a into a is a square. So limit x tends to a, x to the power n is nothing but a to the power n. And this goes for the polynomial function. Okay? Because polynomial function is nothing but the combination of these values only. So you can do it individually. And when you do it individually, you say that this is x tends to a square, a to the power n, like this. So this is fa, which this polynomial is going to give you the value when you place a in place of x. And this also we have seen. We can take limits of the numerator and denominator. And one more thing is that this is just an example that if you take some limit gx, and gx is a function called x minus a to the power k, and this is g1x, hx is x minus a to the power l, h1x, just place it here. This you can easily find out that a to the power m by a to the power n is a to the power m minus n. So this is x minus a to the power k minus l. This you can take individually, this you can take individually, but here x minus a to the power k minus l, and you take x tends to a, you place a here, a minus a is 0, this will be 0, so whatever you do, it will be 0, right? You will understand them more when we take an actual example. So the example is like this. This is x cube minus x square plus 1. Take the limit individually. X tends to 1. So 1, 1, 1. You place it, you will get 1. Again, you can take it, make it x square plus x, or you can take like this only. So place x equal to 3. 3 into 3 plus 1, that will be 4, 12. 4 into 3 is 12. How about this x equal to minus 1? Just place minus 1 here, and you will get the value as 1. All others will get cancelled. Limit these limit. Now this is important. Why this is important? Because this is going to give you the actual flavor or the texture of why we need limits. Because most of these will give you answer as 0 by 0. If you forget about this limit, just for time being, imagine that there is no limit and just this type of question is there, this type of expression is there, or the say p by q form is there, then even if the denominator is 0, this is not acceptable. Only when the numerator is 0, anything x or y is there, that is acceptable, because 0 can be is acceptable, 0 is known. But how about 0 by 0 or anything divided, you want to divide by 0, how can you divide anything by 0? So that is not acceptable. So let us solve this. First is x square plus 1, x plus 100, place value 1 here. We get 1 plus 1, 1 plus 100. You get 2 by 101. No problem with that. Next is, if you place 2 here, hex, in the place of x, if you place 2, then you are going to get 0 by 0. So we are not able to solve it directly like this. You will not just directly place 2 and you say the value is 0 by 0. No. how you're going to solve it, you have to first take x common, then factorize x inside one, which will be x minus 2 whole square. This will be x square minus 4, that is x minus 2x plus 2. Okay, so you can cancel these. X minus 2 with x minus 2, and I'll tell you about this cancelling out also. But for the time being, if you place 2 now here, you'll get 0, and that is acceptable. How you got from infinite to 0, this is the limit. Now again, this question is just the reverse of the previous one. So again, you are going to do the same stuff. You have to find out the factorization, or you have to find the factors, just try to find out the division. But in this case, 4 by 0 is undefined. Anything with 0 as the denominator is undefined, so these two are undefined. This has no limit at the x equal to 2. X equal to 2, limit is undefined. The next one is evaluating the function at 2. If this function x you place value as 2, you'll get 0 by 0, which is not acceptable. So just solve them. Take x square common. Here you factorize x minus 2, x minus 3. You can cancel it out, and x square by x minus 3. Place value as x equal to 2. You'll get minus 4, which is well then better. We can accept it. In this case, if you place value 0 by 0, you'll get as infinite. Okay. So this infinite you have to change. You have to do something in this manner that you get, means what you are doing, you are again factorizing in a different manner. So we are factorizing it in a different manner. Now you can cancel it out. But as I said, I'll tell you what, when you have x tends to 1, how you can cancel it out. Okay, we can cancel it out because x is not equal to 1. We are saying x tends to 1. That means x is not equal to 1. We are saying x tends to 1. That is why we cancelled x equal to x 2 here also. X minus 2, x minus 2. How did we cancel? You must have asked the question that if x equal to 2, then x minus 2 by x minus 2, how you can cancel? This is going to give you 0 answer. So this is a play. This is a joke with mathematics. But it is not. Why? Because x is tending to 2, x is not equal to 2. X is near to 2, but it is not equal to 2. In the similar fashion, you can cancel x minus 1 because the reason or the logic behind is that x is not 1, x is tending to 1. Now you can get the value as 2. So you have got a value which is near to those infinites. So you have got the value as 2. Now there are certain theorems which you have to understand very well, because this is going to give you the correct form when you are going to solve the problems. So limit x tends to a, if it is of the form x to the power n minus a to the power n x minus a. So if it is like x to the power n minus 2 to the power n by x minus 2, it is going to give you n a n minus 1. So n is what here? N. A is what? 2 to n minus 1. Right? And if this is, you have to learn. So how you can get this? If I divide this, you know that x to the power n minus a to the power n is x minus, say this, if you expand it. And since x minus a is the denominator, this gets cancelled out. So actually you are finding out the limit of this only. And if you find out the limit of this, place x equal to a, you will get n a to the power n minus 1. So this is the theorem and this is the result. This is the, you can say that this is the proof. Now similar thing we'll try to evaluate here. X to the power 15 minus 1 to the power 15. 1 to the power 15 is 1 only. X to the power 10 minus 1 to the power 10. So what we'll use? We'll use the same theorem here, this one. We'll place x minus 1 in the denominator and here also, because this is division, no? So x minus 1 we can take, because this gets, anyway, this gets cancelled out. So x to the power 15 minus 1 by x minus 1 is going to give you n a to the power n minus 1, means 15 1 to the power 14. This is going to give you 10 1 to the power n minus 1, that is 9. And this can be easily solved. This is 15 by 10, that is 3 by 2. In a similar fashion, under root 1 plus x minus 1 by x. But here we need some trick. The trick is, you place y equal to 1 plus x. This one you have to place 1 plus y is equal to 1 plus x. So that you get only one value here, one variable here. Under root y minus 1. But x is what? If you take this, x will become y minus 1. So we place x equal to y minus 1 here. Now, anything root is to the power half. So y under root y is y to the power half. 1 is already 1 to the power half. It will not change. Y minus 1. So you get n minus 1 type of solution. N is half, a is 1, n minus 1. So you get the value as half. Now limits of trigonometric functions. Trigonometric functions, see, there are so various things which you can see here. That if you have some function, say f and g, if they are real valued function, and fx is less than or equal to gx, then the limit of fx and limit of gx for x tends to a will always be less than or equal to. Means these two follow, limit will also follow. Because what it is giving is, even this is your gx, this fx is approaching, but it is not going above it at any case, at x equal to a. So this is a. At this point, gx is above, fx is below, though it is touching at x equal to a, somewhat touching, but it will be lower. Then you have sandwich theorem. You can take fx, gx and hx also now. So gx will lie between this hx and fx. So if this is hx, this is fx, gx will lie in between them at x tends to a. So the sandwich thing, let us have an example also. Cos x, it lies between sin x by x, means sin x by x lies between cos x and 1. For x, which is between 0 to pi by 2. So actually we have to take the minus also. But we are aware that sin minus x is equal to minus x and cos minus x is equal to cos x. So there is possibility that rather than taking 0, this mod x, we can take directly x, because these two are anyway going to give you these results. How you are going to find out that these are sandwiched? If you say these are sandwiched, just prove it. Let us prove it. How you are going to get it? We have a point A here. Let us make a unit circle. This is a unit circle. This is A, this is C, this is B. So you have how many triangles? This is OCD. You have triangle OBA, and you have a sector OCA. You have a sector like this. So you have a sector. So you see that the biggest is what? This OAB. So area of triangle OAB is greater than area of sector this one, which is greater than this triangle OCD or OAC. This OCD. This is OCD. Right? Area of triangle let us take OAC, not OCD. OAC, because this is also a triangle. This is because we'll use it. We'll use this triangle also. But right now, just place the value half into base into altitude, and the area of sector is pi by 2 pi into OA square. This is half into base into altitude. Let us cancel this OA. So you get 1 this. Now we'll use this triangle OCD. What is OCD? OCD give you sin x as CD by OA. Actually, CD is OA sin x. So tan x will be what? AB by OA. Similar fashion. So AB is OA tan x. Now in this, let us place these values. What we have found out? This one and this one. So what we got here? Now this particular thing can easily be divided by sin x. Divide all with the sin x. So you get this. Now take the reciprocals. This is the result, and this is what we have started with. So you now knew that by simple proving we can find out that the sandwiching of sin x by x between cos x and 1 lies. Now we'll also prove some more propositions, that is sin x by x limit x tends to 0 is 1. How you are going to get it? Because sin x by x was actually sandwiched between these two. See, we have just proved it. Sin x by x is between 1 and cos x. So sin x by x is between this 1 and this. So if x tends to 0, it approaches 1. Cos x approaches 1. So that is why sin x by x is 1. Now 1 minus cos x by x, 1 minus cos x can be written as 2 sin square x by 2. You have already learned it. So let us write it 2 sin square x by 2 by x. Let us make it x by 2 and take 1 sin x here, 1 sin x here. This is what we have just proven it. We have just proven it. Sin x by x is 1. So place 1 here. And this is what? 0. So you get 0 as 0. And see that as x approaches, you might be tempted or you must be thinking that this was x, but you have taken x by 2, so why not this has to be made x by 2? Because actually we are taking limit as this only. When you have x, you have taken x tends to 0, but when you are changing it to x by 2, you have to change it x by 2. For that you have to give a reason that x tends to 0 means x by 2 also tends to 0. That is why we have just placed it x tends to 0. Now there are some more example. Sin 4x by sin 2x. Let us take sin 4x and sin 2x differently. Introduce 4x here, introduce 4x here, that is 2x and 2 here. This will be 1, this will be 1 if you take limit x tends to 0 for this and this. 2 can come outside, and 2 into 1 is nothing but 2. But here when we take this 4x, you have to change the limit for 4x. You cannot just say that x tends to 0. If you have taken 4x, you have to take it as 4x. If you have taken 2x, you have to take it as 2x. It will no longer remain as x tends to 0. Next is 10x by x. 10x can be written as sin x by cos x. And you know, you take this individually, this individually. This was 1, this cos 0 is 1. So this is 1, 1 into 1 is 1. Right? So this was one more part of the limits and derivative. We'll be taking a few more of these. Thank you so much. Take care of yourself.